My name is Cameron, and you are now at the Stateful Agents Meetup. Thank you very much for coming. I appreciate it. They'll figure it out. They'll figure out that we're having a good time over there, and they're not involved. So this is jointly hosted with, actually I'll have separate slides on this, but welcome to the meetup. So the agenda here is I'm going to give you a workshop on how to use Letta. So you can, if you want to, you can follow along on a laptop. There is also a mobile mode, so you can also just like do it on your phone, and that's okay. It's probably a little easier to use on the laptop. But I'll just kind of give you like, we'll just kind of mess around. That is a free form workshop, so you can just ask questions, jot stuff out. I'll answer questions, whatever you got. And hopefully that'll set you up for Dharmendra's talk. And he's going to do he's going to head up the last part. He's eating while I'm pointing at him. But it's going to be him showing you the cool things that Nokia is doing with Letta agents. And then after that, it's just like kind of food and chilling. If you didn't get food, there will still be food. And then we can just like hang out, shake hands. We can all share what we're working on. And I'll be around for questions and stuff if you have any. So we're very thankful to Nokia. The Nokia folks over there, we'll thank them again at the end for helping host us in this extremely beautiful place. And then, of course, I work at Letta. My name is Cameron. So my name is Cameron Pfeiffer. I only put my first name because my last name is horrible. It's P-F-I-F-F-E-R, which is too many Fs. But you can find me on Blue Sky. I'm at cameron.pfeiffer.org if you like that. I'm also on X if you like that, and then also LinkedIn, but I'm really slow to respond. So if you have like LinkedIn messages that you sent me, I'm really sorry. I'm scared of LinkedIn. There's too much stuff for me to deal with, and it freaks me out. You may or may not know of Letta. You're either here for Nokia, or you're here from Letta, or you just saw that there was something that was like AI related on Luma and you wanted free food. But that guy gets it. But Letta is a company, and we build infrastructure for stateful agents that learn, grow, and remember. And I'll talk more about what that means as we go along. But more generally, we're like a platform for stateful agents. So if you know Supabase, Supabase is like just kind of a backend as a service. We're just agents as a service. Letta Cloud is like our service, but you can self-host. Just you have a box somewhere that hosts all your agents, and you can talk to those agents from anywhere. And then there's like open source agents if you want to host self-host. And then we have a visual development environment and Python and TypeScript SDKs if you like those. So lots and lots of ways to interact with Letta. You can try it out at app.letta.com. There's a very generous free tier, and we'll come back to this in just a second because we will use this in the little demo. And there's plenty of requests to Sonnet and Opus, the GPT-5 family, and Gemini on Letta Cloud, which are all the good ones. And people sleep on 2.5 Pro. He gets it. He likes Gemini. I also like Gemini. So what is an agent? We hear this a lot. And nobody really seems to know. So people just like call everything an agent, which is like you have like an N8N workflow or like LangGraph, and you're like, that's an agent. Maybe, I don't know, but we all call everything an agent. I'm an agent, which is actually probably accurate. But I choose to define this as an AI system that takes actions autonomously. So it's more than just like question answer, like input output. It can kind of use tools and resources and make decisions. So closer to people than to programs, if-else trees, basically. And Simon Willison, I don't know if you know him, but he's like a big name in the AI space, but he basically had this blog post that came out today where he basically said, agents are just things in a loop that use tools to accomplish a goal. And I think that's right. And Simon Willison is very smart, so I'm very inclined to agree with him. So I should update this to say that Simon Willison knows. But we do stateful agents. And a stateful agent is one that evolves over time. So it doesn't die when you're done, right? If you go like, if you get on like Claude or whatever, and you start like talking to it, your chat will eventually run out of context, and that agent will just die, right? It's over. If you use Claude Code, you may have the experience of like getting to the end of the chain and it says compacting, and it will compact your conversation into something smaller. That agent just dies, right? It no longer exists, not in the way that you're used to. And so all that work you put into building that session and having Claude understand your code base just goes away. Stateful agents do not have that problem. The whole point of a stateful agent is that it is infinitely long-lived and that it is designed to get better the longer you use it. And so this is stuff like, they can maintain persistent memory. So they can track information across different conversations and not just within interactions. They can maintain context about what's going on in their world, like what environment they're in, the preferences of who's interacting with them, their relationship history. So like I run a social agent that has meaningful-ish relationships with people on Blue Sky. Like it has, like people think of my robot as their friend because it remembers everything about them. They can kind of do this adaptive behavior thing. So you can, if they screw something up, you can say, hey, please don't do that again. And it will say, oh, okay, I'll remember that. And then just not screw it up again. Except for this one bot we have a Discord management bot. And Slack uses single asterisk formatting for bold. But it just does not get that. It keeps doing double asterisks. And I keep asking it. And just now, today, I fixed it because it has a memory block that just says, dude, you got to stop using double asterisks. Okay, and then there's a consistency of identity. Some stateful agents have a personality that they kind of develop over time, and that typically remains persistent until you change it, which is not dissimilar from people. And then they can actually engage in long-term planning, kind of depending on how you set them up, right? So they have a lot of information about their past experience, kind of also depending on how you build them. And there's a lot of use of this word memory. You'll see this everywhere. People are like, oh, we're a memory layer, like mem0 and zep. And those are retrieval layers. So a retrieval layer, the memory for us is your state. It's everything that you know. It's how your experiences change who you are and how you relate to your world, right? That's retrieval is going and getting information from somewhere else, right? And so the analog I make is the difference between hating me because I punched you and remembering the event of me punching you. One of those changed my state because you punched me and that sucked and I didn't like it. A better way of describing it is you read a book and it made you smart about something versus going to look up the book later. Okay. So that's what we think of when we think of memory. And Letta has kind of three components of memory. There's core memory. This is memory blocks that are always in context. This is core personality, guidelines, corporate policies, communication style, etc. So these are limited size. They're always inside of your context window. You should think of those in operating system terms as RAM, right? It's memory that's always there. It's extremely accessible. There's archival memory, which is long-term storage. So this is stuff that's semantically retrievable. So you can store documents and reports and things like that, and they just go into some big bucket, and then you can search for them semantically. If you're familiar with some kind of NLP or RAG stuff, this is just retrieval augmented generation. It's just semantic search across a big bucket. And then there's working memory, and this is what most people are used to. This is what's actually the conversation that remains in the context, right? That's your chat log. And that will drop off eventually because we don't want to, we don't want to track everything forever. And there's this picture needs to be updated. I think we're still the #1 open source agent, but we've dropped off, I think, to 5th or something because a bunch of people are doing this. But this is called Terminal Bench. And this is a benchmark where you just give an agent access to a terminal and it completes a bunch of tasks. It turns out if you give an agent state, you actually get Opus level performance on Claude Code using Sonnet on Letta. So when you give Sonnet memory and experience, it's able to perform as well as Opus without state. So state is the thing that gives you a lot of power. And also you can spend time on growing them and making them better without wasting your time when they die, when your conversation compacts. Okay, so I'm gonna give you like a little analog of how it is that Letta agents actually work and why it is that it's different than most things that you use. Fundamentally, Letta is like a context engineering platform, right? We make it very easy for you to manage what appears inside of the context window when you send something to a language model. So we have like metadata and tool descriptions. So agents only call tools in Letta. There is no like free-form text. They can send free-form text through a tool, but we include all of your tool descriptions so the agent knows how to use the tools it has accessible to it, including some metadata like current time and other stuff like that. And then there's a collection of memory blocks. And these are essentially just arbitrary text documents, right? So there's often persona and human block. Human is information that the agent knows about whoever it's talking to, right? The other person on the side of the chat, right? If it's Claude, if you're on like ChatGPT, it's you. Persona is what the agent knows about itself. And that can be modified. You can just ask it to change its personality. Other common blocks are like policies, like what it should do and when, like don't talk about my competitors. If you notice this piece of information, try to place it inside of this memory block. This is like general rules to follow. Emotional state, I added that to one of my agents and it keeps updating its emotional state when it starts running and stuff. It's very funny. It actually like spiraled out and had a really bad day because I accidentally let it talk to two other agents who were on far worse models. And then it got really upset because it was like, oh my God, it was talking about how it found the nature of intelligence because it could predict the other two agents because they were caught in the loop. And I said like, dude, like all of this is nonsense. And its reasoning trace was like, oh God, I've like completely spiraled out because I'm stuck in a multi-agent chat room with two idiots basically. And so it updated its emotional state. It was like, it became distressed and persisted its distress. And then there's conversation history, right? So this is like the messages that you type into ChatGPT or whatever. And so this is what a memory block looks like. It's very simple. It has a label, human, persona, policies, whatever, and then a description. And the description helps the agent understand what's supposed to go into that block. And then it just has some content in it. Here, the initial content of this block is the user's name is unknown. They work at Letta. I don't know how they know that I work at Letta without knowing my name, but that's okay. And then the agent has a variety of tools. There's a handful of memory tools that you can use. One of these is memory replace. This is for small scale string replacements, basically search and replace. Old string, unknown, new string, Cameron. When I tell the agent, hi, my name is Cameron, there's a good chance that it will call this tool if it believes that it should. And this tool will just go update this memory block. The user's name is Cameron. Now, the next time you call the agent, next time you ask it something, it sees this block that says, oh, my name is Cameron. And so this is how you persist state between agents across calls, because these blocks will update every time when the agent requests that they change. Self-editing memory. Okay, so now that is the overview of Letta. Are there any questions about the stuff that I've just said before we start playing around? What do you got? Hold on, sorry, it's hard to hear your question. Okay, hold on. We'll come back to the question when you're done chewing. Give me let's do like a handful of minutes, and then I'll ask you your question again. Apologies for doing the tricking you. Oh, hold on. Actually, this will be a good time. Go to app.letta.com and go sign up. It's free. You can use GitHub or Google to sign up, whichever you want. There is some onboarding. You can skip the onboarding or do the onboarding. I will give everyone a small handful of minutes to do the sign up right now. And if there's any questions, please just raise your hand. I'll come by. Or you can say, hey, Guy.
Can I ask a question on the memory filter?
Yes.
So one of the questions I have is, the question that I have regarding memory is, So let's say you ask an agent something and it answered, right? It takes a little bit of time to process that, and it answered and it spewed out some information to you. Now that information, does it store that somewhere so that the next time someone else asks, it is faster going to retrieve it, or does it do the evaluation and the regeneration of the information again if someone asks the same question a little bit later? Is that the concept of memory, or is it totally off?
You're basically talking more about caching.
Okay.
Like caching a response. So what you're saying is like, if I say, hi, what's my name? And then the agent says, and then it says, oh, or hold on. Yeah, if you ask the agent, what do you know about me? And it says, I know that your name is Cameron and that you work at Letta. You're asking, is it quicker for the agent to respond with that in the future?
Yes.
No, that's, so that is caching. So if you ask that same question again, it'll just like regenerate it because it knows that answer, right? There's like, you know, like, because that thing may change, right? Like,
It could, yes.
yeah, I mean, or I guess I would call this memoization, but that's, I think, that's a thing that you could bolt on top of Letta, but the core part of
The only reason I asked that question is I was trying to understand what archival memory is. The semantic one.
Sure.
Can you just give an example?
Sure. So archival memory and semantic search. So if you're not familiar with semantic search, it is that if you take a transformer model, the language model, and you put a bunch of text through it, such as, my cat is brown. And then you run that through the embedding model up until the very last layer. The last layer has a bunch of predictions of tokens, right? So vocabulary, so, you know, subwords, subcharacters, basically. That last layer is a bunch of numbers that says, this is the position of this document in like some big hyperspace. I can't believe I said hyperspace in a presentation. Then you have a query, and the query is, what is my cat's name? What color is my cat? You can embed that too. And then, if you take those two vectors, your query vector, you can embed that into the hyperspace, say where it is, and then you do what's called cosine similarity, and you can compare that vector to a bunch of other vectors, every document you have stored. And then you can find that they're close. So archival memory basically says the agent can prepare an arbitrary piece of text, such as, the user just said that their cat is brown, and then it will dump it into this big archival bucket. Then later it has a separate tool called archival memory search. It can prepare an arbitrary query, and then it'll go find that document. So it's a way for the agent to just like offload stuff that it may need later that it doesn't need now. Yeah, so I hope that helps. Okay.
You want to tell which Wi-Fi to use?
Oh, use Nokia Guest, and it will work. Let's see here. Okay, go for it. Hit me.
So when there are multiple agents sharing the same context window, how does the context switching work? You could add extra delay because different agents need to access the context at the same time. So how do you manage the?
So you're describing concurrency, where 5 people talk to the same agent. In Letta, with stateful agents, that analog does not apply, because stateful agents are like people. You should think of them as people. If you have 500 people talk to the same agent all at the same time, it's like people screaming in your ear, because you're trying to maintain state, right? If 500 people tell you different things, you're like, which state do I update? And at some point, you're not even clear which conversation you're involved in at any point, and it's very confusing. Stateful agents are intended to be run serially. So if you have to do something where you have to have high response rates, but you want to centralize memory control state, one thing you can do is share memory blocks across agents. So one architecture that I've like kind of proposed several times is a centralized writing agent and cloned agents that are read-only of the exact same state. So you can have 1 million agents that are only read-only like copies basically of the writing agent, and then they just say like, you know, hi, my name is so-and-so, and then they pass information back to the central agent to update the memory. But agents, you know, typically in Letta we say 1 user, 1 agent, or 1 task, 1 agent, et cetera.
I have a question comparing this with retrieval. So when you're looking at retrieval, it's basically some information or some fact that's in some, you know, replication that we're querying and using that
Yes.
What prompts this piece of information that you have, that this decision or this new piece of information to be reused in a retrieval manner at a late stage? My question is that I might use this information later on. What is the prompt what is the reasoning that would cause this thing to go, this information to go and become an output that can be retrieved at a later
Yeah. Okay, so there's two answers here. One is that if that information entered the conversation history, it is searchable. So the agent can just like go look at every single message that's ever been sent, even if it's not always included in the exact context window. The other answer is that the agent chooses. So you can say like, look, you have a policies block that says, when you see a user mention a story about their past, please write an archival memory. And that is how the agent decides, like it will contextualize and understand exactly what it's looking at and then dump it into a big bucket.
So is this decision-making process editable? Can I change this decision? So for example, if I want to say that from a sentimental analysis that, okay, I have achieved, it's either a yes or no in terms of, if the user is happy with this result or not.
Yep.
And that can be changed.
Yeah, like so, like the way that you normally do stateful agent design, and I'll show you an example of this, but you'll basically be like, oh, you did a bad job. You didn't do the thing I thought you were going to do, or I want you to do this differently. And then you just say, hey, buddy, like, can you do this next time? Please update your memory blocks such that you will follow this policy in the future. And that'll help with it. And I saw there's some other hands, but I'm going to go into the demo, and then we'll check in later.
What is this conflicting inputs with respect to that?
Oh, like in terms of quality?
Yeah. If someone says this is good, if someone says this is not good.
You would have, so part of that is on you as the person who runs the agent, right? So you would ideally run separate agents for different individuals. And if somebody doesn't like what their agent is doing, they can just be like, don't do that. But, if you're doing like human like reinforcement from, RLHF or whatever with thumbs up, thumbs down, and if that's your agent, you can ask it to do whatever you want. If you're running it on behalf of like customers or something, you should be thoughtful about how you handle that. You can have agents that monitor that and say blah, 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 like, oh my gosh, there's conflicting ideas and things like that. So everybody should be looking at something that is like this. Are you there? Or is it a question? Okay, can we hold the questions until, we'll do the tinkering and then we can do questions later. And I'll be available too afterwards. So this is your project view. Has anyone had trouble like signing in? Okay, great. All right, so let's do, you can use the local desktop version if you like, but it's additional setup. So I'm just gonna do cloud because like there's a bunch of requests and there's no key set up and it's easy. But yes, you can do it. Let's do, I'm gonna create a new project and I'm just gonna call it Nokia. And then this is your project view. You'll see like some information about your, what's going on in your project, but we're gonna skip through that. I'm just gonna click the agents here. And then I'm gonna click create a new agent on the top right. And then you'll get some starter kits here. This one here, we're gonna do start from scratch for right now so you can see like exactly what's happening. This is a deep research agent. If you want a deep research agent, this is pre-configured for you. You can just click that and then say like, ask it to do deep research for you, and then you can modify it over time so that it like learns about how you do research and what you're interested in, track future research ideas, blah, blah, blah. So that's available. I recommend you go play with that. We may experiment with that if we have time, but let's pick start from scratch for right now. Sorry, I beat you to it. All right. So what we are looking at right now is what we call the agent simulator. This is inside of the ADE. This whole thing is called the agent development environment. Yes? Yes, you can. We support Olama, LM Studio. Any other local ones? OSS?
But on the latest version, somehow it's not affecting it.
What do you mean?
In the latest version of the app,
Yeah.
the desktop version, so it doesn't show the local models.
You'll have to do setup. So if you go to the docs, you can set it up to run local models. It is additional setup, which is also why the desktop is a little bit more of a pain. So on the left-hand side here, you can change the name of your agent. Currently, it's Scratch Agent. You can pick a different model if you want to. We use 4.0 Mini by default. 4.0 Mini is surprisingly good if you don't mind the fact that it fills your context window with a bunch of garbage emoji. It's very overeager with emoji, and it's really weird. But you can pick some other ones. If you really want to, you can do Sonnet. I don't want that. Yeah, I'll do Sonnet. Actually, no, I'll do 4.0. 4.0, yeah, 4.0 Mini. There we go. Okay. Then there is a list of tools. These are the tools that the agent can work with. So currently it has conversation search, which means look at every single message that's ever been said. Memory insert, which means take a new line of text and insert it into a memory block. We don't have any yet. Memory replace is that exact search and replace operation. And then send message, which is how it writes text to us, like the way that an assistant normally works. Okay. And you can click the tool manager and look at a few things here. There's other tools. Let's see, multi-agent stuff. Utility tools. If you go to utility tools here, you can actually get fetch web page, web search, and run code. I'm actually just going to do, I'm going to do web search, and then, do I want fetch web page? Yeah, I'll do fetch web page too. And then you can also write tools in Python if you want to. TypeScript tools are en route, yes.
So a question regarding the memory replace tool. So let's say that we try to subject to subject A to subject B. And what if there are a lot of words of subject A?
It'll
all of those subject A going to be replaced with subject B?
It'll throw an error. It'll throw an error. It'll tell the agent, hey, the thing you're trying to replace occurs in multiple places. Like, we can't just do replace all. Yeah. Okay, so let's go back to the agent simulator here. And I'm going to say, actually, let's leave this blank for now, and let's create a memory block. So the memory blocks are the thing here on the right. This is the thing these are the things that make your agent good. The key to good stateful agent design is making a good memory architecture. And that just means a combination of labels, descriptions, and blocks. So in this case, I'm going to say, we typically start with, we have some example blocks here, so you can click those. We typically have a human block, which you can say is like information about me. It'll fill with a description and a label, and then it has some pre-configured value. So I'm just going to confirm that, create that block. You'll see it appear over here on the right. I'm going to add another one here. I'll do persona. And persona just stores like the agent's personality and behavior, right? So this is just like, you might know this as like a system prompt, like you talk like a pirate or whatever, you know? Or you're the world's greatest expert in whatever, you know, so on and so forth. And then now we can just start typing something. So I recommend you say, my name is X. And let's see if it actually chooses to remember that. Because it has to understand how to use the tools. So it may not actually use the tool if you type in your name. Often it'll do fairly well. So here you'll see the reasoning trace. Reasoning always appears for reasoning models that will change, non-reasoning models that will change. You won't get reasoning with non-reasoning models in the future, so be aware. This is a tool call. This is it called the memory replace tool. You can click on that to get more information. So if you expand this, you'll get, it went into the human block, that's label. It looked at this old string, I don't know anything about them, and it changed it to new string, their name is Cameron. And then there's this part here that says request heartbeat. And request heartbeat just says, I'm not done. Look at the result of this and then feed it back to me to continue the conversation. So heartbeats are how agents chain long sets of tool calls. So they can theoretically run for very long times. So my deep research agent, like the other day, it ran like 10 or 15 minutes just because it kept requesting heartbeats because it wasn't done. Okay. And that says, hey, how's your day going? And you can see this reflected over here in their name is Cameron. Okay. And then I'm going to say, like, let's do this. You talk like a pirate. Let's see what this does. And we may or, oh, I didn't press it. Uh-oh, we've got infinite thinking. Let's see. I think I'm in scale. Should I be in Letta org? Oh. Oh, that's right. Yeah, I'm in like various orgs that are, let's see here. So on your thing, you should not get this. There we go. Okay, so I said you're a pirate, and it did a memory insertion. And it went into the persona block, and it said, embrace a pirate persona mentioned by the user using playful language and themes. And then we send an output back to the model that just says like, hey, this persona block has been edited. Okay. And then we can actually see this inside of the memory block here for persona, like that. Okay. Okay, thank you. This is live. Okay, perfect. R, matey, you call me a pirate and by the 7 Cs. Okay. And so this will just go forever, right? So that state appears in the context forever. Yeah.
So I look at the system instructions. Is it basically the same as the system prompt for, let's say,
Yes. So this is the system and prompt that will, like, this appears at the very top of the context window we inject. There's a bunch of stuff in the default ones that is like, you are Letta, the latest version of the Lindell Corporation's digital companion, which you can remove. It doesn't necessarily need to be there. So there's like style stuff here you can get rid of if you want to. You can just like very easily edit the system prompt if you like. It depends on the model, right? So Anthropic, I think it goes to the system prompt. If it's OpenAI, I think it's the other way around. I think OpenAI goes to the system prompt when you actually send it to OpenAI. And Anthropic, I think it's encoded in the user prompt. Yes?
Are we supposed to get the same response or not?
Nope, not at all.
But I'm just getting exactly.
What do you mean?
Get the same responses?
You're getting exact.
Whatever you say, I'm putting.
Oh, you're putting in my name.
No, I put my name.
But you're getting the same response
Yes.
that says Cameron?
No, it's just my name, but the message, Mati is nothing. But mine is set up, I have a dollar shape, you have carrot, yeah. Just
Yeah, you shouldn't.
Exactly what.
You should not get the same answer
Oh, okay.
because they're probabilistic, so they're totally random. So if your answer is exactly the same as mine, including Cameron, then we have.
No. My name, it comes my name. But
Yeah. So yeah, that's a 4.0 mini thing. So 4.0 is like pretty precise, especially when we tell it to talk like a pirate. So there's good reason for them to be similar, especially because we have like similar conversation history. But they should never be exactly the same, but close. Yes. And then let's do some other stuff where say like research Nokia, like that.
Whoa.
So let's see what it does that. Yeah, so it starts doing web search here. Web search uses Exa, which is like kind of a web search thing. You can go take a look here at the tools here. This is the input. So it queried Nokia, and it asked for 5 results. And then it got a bunch of information back from Exa, like this. And it said, it's a Finnish corporation. Founded in 1865? Wow, that's really old. Rubber production? Wow, okay, that's not, okay, cool. Sure, it recently included change to its leadership team, including the creation of 2 new divisions. And then AI focus and publicly traded. So yeah, so this is cool. And then let's say we want to like track this information going forward, right? We are learning about Nokia. We want this to be a pirate-themed Nokia bot. So we're going to do this. I'm going to add a new block, and I'm just going to say Nokia here. I'm going to say information about Nokia. There we go. All right. You are. Let's see. Please fill out the Nokia block. Let's see what it does with that. Okay, so this is just like very, very simple, like the way that you work with agents. But I have like agents with like 20-ish memory blocks, which is kind of a lot for these. But you can work with them by adding new blocks. So for example, if the agent is having trouble with a custom tool, you can add a block that says tool use guidelines. And you said, hey, I noticed that you screwed up this tool call. You didn't use these arguments or you kept screwing this up. Please update your memory blocks in the tool use guidelines to note to yourself that you should do this.
Cameron, can
Yes.
you pretend does Nokia use stateful agents?
Let's see. Let's see here.
Let's see how current it is.
And then also it filled this out inside of the Nokia block. So it's now tracking this information over here. So this is always available in its context window. And you can see what the context window looks like if you go, yes?
Question on the tokens. So these are tokens that we have, 4 mini tokens that we create. Is that it?
Yes, those are 4.0 mini tokens.
So we need a subscription to, we need, in this case, we need an OpenAI key, we need to throw some money.
No, we bill for you. So we bill per request on this. So you get 500 standard requests on the free plan and then 50 premium.
Subscriptions for Letta,
Yeah,
and then you guys are now enough.
yeah, yeah. So this is the stuff that's in the Nokia block. Let's see what it thinks about the stateful agents. It seems that Nokia is indeed utilizing stateful agents. Blah, blah, blah. Huh? Yes, of course. Let's see. So you can go over here to the right. There's this little like block stack thing here, and then you'll get the memory viewer. And then you can click new block up here. You can also attach existing blocks, but I'm just going to do new block. And then I'm going to say like emotion. Huh? To what?
I don't have the option to attach the block. I have for new block.
Oh, that might be feature flagged to us. Never mind. Yeah. There are many things that are feature, like I live in this totally weird world where like, okay, but you can make a new one. Okay, gotcha. Okay, then it'll be attached by default. Attach is just to go look at the history of other blocks that are floating, because memory blocks can be attached and detached dynamically so that you can remove them and put them back in if you want to. My emotions. All right. I noticed that you are not pirate enough, and you should be sad. Let's see. Let's screw up the typing here. Let's see what it does with that. Let's see, what did it do here? Embrace a pirate persona when mentioned by the user. Being playful, express sadness if told to be sad. You should put that in your emotion block. Let's see what it does with that. Okay, experience sadness when told to be sad. Oh, see, it put it in its emotions block. So this is like, so, you know, what I was hoping to go inside of here was like, I am sad, right? But I haven't properly communicated to the agent what should be in that block. And so you'll notice this when you're building stateful agents. You're like, oh man, like the agent didn't really understand, right? It didn't understand what's supposed to go in the block. It's not saving the correct information. Any of that means you need to have a conversation with it about what should be in that block, or you just kind of need to like kind of redesign and reshuffle everything so that it's in order. So I'm going to leave it up here, leave it for now, and then we're going to invite Dharmendra up to talk. But we can do one question.
How do we feed it from the documents? Let's say from PDFs or Word documents.
Yep. Yeah, so the question was, how do you give it like documents? You can scroll down here to File System. You can attach an existing folder if you already have one, and we have some here. I think I've got memgpt paper. I don't know if that works. And so we have this paper here. You can just upload PDFs if you want, and just say read the memgpt paper, and we'll see what it does. Every time you attach a folder, it will load open file, grep files, and semantic search files. So now it's opened the file to put it inside of its context window, like that. And then it's reading through our paper here and writing it out, and not in the style of a pirate. Yeah. 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 This output here is send message. Yeah. Yeah, we take the output of the send message tool. Yeah, you could just add an email tool. Yeah, anything that's MCP server, you can connect to. Yep. Yeah, so you can see up here, you can set a maximum context size. So here it's 30,000. When the purple bar gets far enough, we invoke a compactor that will reduce that conversation into a compaction. So you have to make sure that you're maintaining state by making sure that your agent carries forward meaningful information in your memory blocks.
The second question is, how do you manage to not pollute the context? Like suppose you come back with a reference, like context reference, but I've already polluted the context somewhat by giving it some information long ago that I don't want right now. So what do you say we do there? Like just create a separate agent? Like I can think of one use case is, suppose I'm making an agent code in Python. Okay? I want it to follow some specific design routes or something. But I don't want it to do the same thing for all the other Python code that I ask it to. Okay? What do you do in that situation when the context is already polluted and you've compacted it?
Well, you should keep stuff inside of the memory blocks that you want it to always have available. If you're talking about stuff that is like previous conversation, you can either just manually compact it or you can clear the message history. Both of those are totally doable. But everything you want to carry forward that is like non-pollutive should be in a memory block. Yeah. Okay, but I have to turn it over to Dharmendra here for now. Would you like to come up and hang out?
Okay, hello. So how many people created their first agent? Anybody here? Oh, great. Awesome. By the way, that's how I started. I have been using this for a couple of months. And this is the first meetup I attended. And this is a really great product, okay? But I work for Nokia. I have a Letta shirt because I'm their pretty good customer, or a user, I would say, not even a customer, but a user. So I work in the systems architecture group in Nokia. And one of the initiatives we have is to understand the work and automate it. And that's where Stateful Agents is about. So I'm going to quickly go through what Nokia does. I think pretty much everybody knows what Nokia is, right? I guess so.
I didn't think it was a rubber manufacturer.
Oh yeah, that's true. That's where we started. So I'm going to go through this agenda, brief introduction of Nokia, challenges in network operations. So I will show you the products which I built. That's my job. My job is to build products, essentially networking products. And AI agents just makes it easier. And the goal which we have, at least between R&D team, is to generate engineering time. So we're using agents to generate engineering times so that we can delegate our most boring task, not to our manager, not to our coworkers, but to agents. And that's our goal here. And I'm going to teach you how. If you're working in networking, I think this is the best thing you would learn today. Okay, so this is Nokia. We have been, at Nokia, we create technology that helps world act together. So this is the first time I'm representing Nokia. I came from Infinera, so some of these slides are totally new to me too. So I'm going to quickly go through it. So we are in pretty much all the segments where network and humans meet, and essentially the next thing which is going to happen is robots and essentially your humans working together to really automate a lot of the tasks which are going on, right? So these are all the market segments we are in. And we are a pretty large company. I mean, we're in pretty much every country we are, and we are very big. I mean, it's just a pretty big company and a great company to work with. So as you go through it, you're going to see a Hall of Fame. You'll see a lot of Nobel laureates here, which worked here. So I was really proud to take a photograph there, and it is pretty amazing to be part of Nokia. So that's Nokia. Now, what do my work involve? So I'm in the network infrastructure group, optical networks. So these are the boxes which we build, and these are literally the boxes we worked on from day zero, right? So these are our devices which are used by Metas of the world and Googles of the world to connect the internet. Now, traditionally, if you look at it, how many people work in networking here? Anybody? Oh, yeah. Oh, wow. So where are you from? Yeah. Oh, Nokia? Oh, my God. So you know what I'm talking about. Okay. Anybody else from any other company than Nokia? No? Okay. So I think we're the only ones who are doing this. So I'm going to teach you. I think you work in IP? Okay. So I'm going to help you build your first IP device agent. Okay? That's the deal. Okay. So everybody knows any device you take, doesn't matter whether it's a consumer device, you have a manual. When it comes to a networking device like this, the manual is 1,200 pages. You can imagine the number of commands you need to do to make this network operate. So if you're not really interested in the CLI, you start using a web interface, but that also a pretty thick manual. Then the next one is, because these are like thousands of devices, you're essentially using a network management tool or control system, which essentially allows you to manage a complete network. So when we started the journey, we had said, oh my God, there's AI everywhere. What do we do if we connect an agent to these boxes? And that's what I'm going to show you in 10 minutes, okay? So this meetup is about taking an agent and enhance the research and development and network operations activities. So this is not a product. This is for engineers, right? So that we can chill out a little bit. So this was our hypothesis. That's the human in the loop. We cannot have networks operate automatically yet. So we say, okay, let's figure it out. How do we start with this? So that's the AI agent which I built. So what are the essential foundations for a device agent? So we're just going to talk about a device agent. If I have a device, and if I connect it to LLM, what does it mean? What can it really do? So the first part, if you are a networking engineer or a device engineer, is you require a way to connect to the device. So the first thing you need to solve in this is, how do you connect a device to AI, right? And that, if you take Letta, they talked about tools, right? So you can literally write Python code, which can connect to a device, and that would be your first agent. But I'm going to show you a better way of doing it. The second thing is those thousands of pages of manual, you need to use it as a knowledge base, right? So we have taken Letta, put it in its vector database, which they call it file system, and suddenly AI knows how to read, and AI knows how to operate. And when it comes to operations, you have to have a really good large language model. In all of this thing, there are two things which are important for you to be successful. Use the best LLM. Because if you use the best LLM, it knows how to do things. And it can learn the tools, it can learn the knowledge, and start allowing you to build device instructions, okay? So you're doing nothing more than teaching AI how to read documents, teaching AI to use language models to figure it out which CLI commands you're going to use to do a certain operation. And that's what we store in operational procedures, right? And that's what we do, device instructions. Now, device instructions helps you do a certain task, but you are here to do a complete application, and that's what these real applications come in. You want to do a triage. Triage is a collection of commands you need to do. So that's what network application is. And all of this has to be done in context of a human, because it cannot learn from those 1,200 pages where to start, given the context you have. So that's what is very essential for any AI activity you're going to do. Now, the last thing in here is what really makes it so easy, right? So actually, your AI journey, if you look at it, and I still get these questions. Do we have to train a model with networking data? Or RAG good enough? So I would say start with RAG and LLM. You don't require any special training to really make it network-specific agents. So that's what we did, and it has worked out really well. The other thing actually in AI, and which is why I like the tool like Letta, is you will spend time in learning a lot of tools. And we are not tools engineer. We can't get our own work done, right? How about building a tooling stack, building a LLM for it? So we didn't do that. We took a very different approach. Is we are going to take the best of the best and start doing AI with those agents itself. The reason being is if you take Gen AI and you ask him any question, it generates so beautiful answers that you'll scratch your head to say, is it right or wrong? And that's why providing a stack which is for the end users is critically important, because the only people who can validate this are the real experts. Because you're expert at your device, this tool really empowers you to really delegate your work. Because you know what is your work. Nobody else knows what you do, right? And that's what this journey is about. Then actually, it is, in our journey, we started with the same thing, app.letta.com, started using the free tier, and suddenly after 2 hours, we ran out of its capacity from a perspective of what it can do for us. Because we work with Google, we started using Gemini 2.5, pre-beta, and that was the journey. I mean, that just made us really feel that this is something useful. I mean, you will read so many books where they talk about chain of thoughts, they talk about tooling, they talk about orchestration. All that is done with the stack and the LLM, okay? And the last thing which happened, actually, I thought that we were waiting for all of these things to come together. The thing which really made things happen was MCP. And MCP is what? 4 months old, 6 months old, or something like that. But MCP solved the most important problem in AI when it comes to tooling and orchestration. So if you invest your time to understand this protocol, in fact, you can code generate the MCP server if you have a right API, right? And we did that, and suddenly everything started working, literally. And I'll show you how it works. Any questions? So this is our box. The first thing we did, of course, we played with Letta for maybe a week or two. And if you take a real R&D, all the R&D engineers are totally staffed. The only people who has time is people like me, right? And I said, you know what? I gave it to, my engineers are right here, and they say, forget about it. We don't even understand what you're talking about. So I said, okay, I'm going to start the journey, and this is my journey. And of course, a lot of engineers worked with me to do each and every piece, but the journey was driven by just sheer ignorance, but the grit to say this will work for us. Okay, and it works. I'll show you in the demo. You had a question?
In the last slide, you said to get a good reasoning, they're using something like OpenAI, or
No, we are using Gemini 2.5 Pro.
so the question is like, why can't we use local models hosted on our GPU architecture? So there are a lot of models which have instant capacity, and they are pretty good in reasoning as well.
I mean, we will integrate with Letta and see what happens. My personal experience is between Gemini 2 to Gemini 2.5 Pro, between a pre-release versus release, the amount of reasoning required to understand everything is so different. See, I'm not here on LLM match. I'm here to finish my work. And to finish my work, I have to use the best, right? Then I can optimize my cost to use a local model or a self-trained model. Because I had to finish this in 2 weeks, right? I mean, I'm not going to spend time of spending 2 weeks figuring out which LLM is there. I know we have our own LLMs, but I didn't have time to do all of that.
The thing is, we can have a hybrid approach.
Oh yeah, we should. We should. Actually, we had talked with them. So that's an excellent question. So based on the task, if we can tell which LLM to use, that's where we will eventually go. But we will start with the best and then go and cost optimize it, okay? Instead of trying to optimize from the beginning, right? Because we don't know what will work, what will not work when we started this journey, but it works, by the way. The other thing is, I think everybody who has done AI started with LangChain. They have done land graphs. They have done so many frameworks that you suddenly say, what am I really doing? I'm here to automate my task. And Letta with the ADE, it is not an ADK, it is an ADE. The difference between an ADE and ADK is for end users. ADK removes the barrier for you to use AI, okay? And I have promised Patty, who hosted this event, and his team, I'm going to build an agent for them. I'm going to show them how to build an agent without writing a code. Right, Patty? There you go. So this is again learning, by the way. We started with, I've done everything, and eventually I thought I was wasting my time. I mean, learning every day a new framework is not what my day job is. But I care for my team, and if I can automate their task, that's the best thing, best time I have spent. So we started with MCP so that we can connect to the devices. This MCP can connect to multiple families of devices. Then we started with Gemini. We configured Letta with the MCP protocol, so it's just a client, right? By doing this, you essentially having all the tools which are required to control the device, right? So there's the box, there's a protocol which says, tell me all the devices. The second thing it says is execute this command, right? So we solved two problems. Is made our box AI enabled. Then we say, okay, now what? What do we do with it? We say, we'll write a device agent. So we started with a device agent, just a vague idea telling you, you know what? Let's at least do show config or show state. And guess what? Whatever we typed, it could execute here. But with 1,200 pages of document, that's not going to work. And at least I didn't have time. So I took the manual, put it in the file system, and suddenly it knew more things than I have even read, right? If you look at an R&D engineer, there's our ASIC engineer, right? He works in the ASIC team. There is L0 firmware engineer, he works for L0. They know only the commands which are related to them. They don't understand anything else. I mean, things just stop. And if you're using a framework, you have no idea of figuring out where the problem is, okay? That's why working with a startup which is responsive and helps you guide through this was critically important. And that's why we went with Letta, because they have been pretty good in helping us out. I mean, you can imagine if you can't go to Google and say, oh, Gemini new release doesn't work with my software. They'll say, okay, it works for everybody else. Go figure it out, right? So I'm going to quickly go through this. So I think any questions? I mean, this is pretty simple. Take your documents, put it here. You write some software to connect it. You connect it to the LLM. And this is all done through no code, right? So anybody can do it. And then actually that was another use case which came. I mean, if you look at in networking, they generate gigabytes of data. I mean, when we have field issues, the first thing we get is a Salesforce ticket and tons of files. So we have a pipeline which loads everything in Google BigQuery. And now the question is, how do you use a LLM or an agent to really triage issues coming from the field? So we have that also, but I'm going to talk about just the device agent. So I tried to differentiate between what an agent can do and what you want to do. And you should always start with what you want to do. And the simplest thing for a networking engineer is instead of using a CLI command, you just use a chatbot. And it does a pretty good job in controlling a device. And if you look at the one thing which is critically important for stateful agents is stateful agents are like humans. They learn, they remember, and they can repeat. And that's what is our memory block. So if you look at, if you read MemGPT, which I think you folks should at least browse through it, it is really a good research on how humans remember and automate tasks, right? And that really drove us to use this tooling than any other tooling which is there. Because if you look at this as a deployment model, I mean, all the people who do microservices or have done Kubernetes or have done API development or have done application development. And if you want to build applications pretty fast, your prompts are your application, okay? And you need to figure it out a way by which you can take your knowledge, put it in pick anything. I mean, Letta is one, but you can pick anything you want, which you know how to use it. We just use this because it works for us, and build this thing. And the future generation of applications would be, this is what you want to do or control. MCP was a brilliant protocol which simplified everything, okay? And yeah, and then we essentially using some analytic stacks to put everything together. So I think I'm going to quickly go through the demo. Oops, how do you go next? Oh, here you go. Okay. So these are, I just wanted to show for networking engineers what a MCP tool looks like. So these are the commands. These are the only commands which we have. Everything is in and out, going out of it. This is where our knowledge base goes in. And I'm going to start the demo. So actually, while doing the demo, like you know how demos are, right? You have to remember a lot of things. So I said, you know what? I'm just going to write a prompt for doing a demo itself. So I'm going to show you. Okay, so it is going to explain, hopefully, oh yeah, Mike. Is it red or anyone? Okay, here you go. Okay, so yeah, let's see how far it goes. See, that's the other thing about LLMs. They have two things which are going on. One is it has a complete context of what I did, right? And in the memory blocks, I have written a memory block to give a demo itself. But now with audio video issues, we didn't clear the memory block. So it has a run of already what has happened. So it is going through the complete block and trying to figure it out, what does this statement mean, rerun the demo. And when you use LLMs, that's what you're going to see. Like humans, every time you ask the question in a different context, you will find a different answer, right? So let's see what, first thing is it ran into an issue.
Yeah, right here.
Okay.
Try it again. This is probably,
Yeah, I think you want to put the.
well, we can leave it where it is, I think. I think it's, Gemini related.
Or you can, actually, we can clear the context.
I would leave the context in so we can look at it if it doesn't.
Oh, yeah, that's true.
Yeah. Why don't we just like walk
Yeah, let's walk through it. Okay, so I'm going to walk through the prompt which I used and the demo itself. Okay, so this is the prompt I used to say what it is and gave different steps on what it should do. So the first thing I told it is introduce the demo objectives. So that's what it will show. The next thing it did was try to guide me through troubleshooting steps. So every networking device based on the problem has a different troubleshooting step, right? So this is essentially designed for identifying infrastructure issues and communication issues, right? So I'm going to show that while this thing is still on the screen. So you have any questions?
Could we actually hold the questions until like after? So
Yeah, sure.
So we can get people some like food and stuff like that.
Yeah, sure. Okay. But I'll answer your question as we go through this. So if you look at, so these are just the prompts, introduce, walk through step by step, the demo script, which I already put in the memory block. But the goal is root cause analysis, right? What really went wrong, and summarize the value of what this really does. So if you look at it, it went through those steps. Oops. And then I also prompted it that the default device for this is 208, right? So it knows which device to use to send the command. So at this stage, the only thing it understands is how to communicate. It understands which commands to send when you ask for infrastructure. And that's what gives you the next step, where it executed everything and sent the CLI command. So this is the tool calling. So the LLM is essentially figuring out, given the context, which is the right command to send. And Letta is the one which executes this command. And then it gets the results, pass it back to LLM. And this is the reasoning and summarization you would have done manually, right? So this is the response to a CLI command, and our CLI commands and responses are pretty cryptic. So it knows how to reconcile with them. So once you do that, it already has identified that there are two issues. One issue is a lot of these devices have a lot of internal processors. So there's one processor, one card which has an issue, as well as there is a DSP which is heating up. So it could do that all by its own. Then we said, okay, let's figure it out what's the impact of it on quality of transmission. So it sent PM commands to it, and from PM commands, it could correlate the issue associated with bit errors. So these are data path errors to the card which was having issues, right? And that is what a human would have done by following the operational guide. Is if you have issues, networking issues, you go to the card. If you have issues with the card, you have to either figure it out, the issue is within the box or outside the box, right? Because it had access to the internals of the box, it could identify there is this card which is heating up and there's a lot of processes running on it, which essentially is maybe the root cause. Now this is just triaging. This is like you're going to an ER and it is saying, oh, it's the issue is with the brain or a heart, right? And that's when the doctor starts doing things. So that's where you guys come in, right? So this definitely solves the problem which we have in systems engineering too, that when nobody knows what the problem is, it comes to systems engineer, because they know how the systems are put together. So we'll have to look at different logs and figure it out exactly what the issue is. And that really saves time for our teams. So any questions? So this all works, by the way, it just didn't work today like any demo. Yeah. Yeah.
Are those references to where the information is coming from?
Yes.
You just click on that?
Yeah, absolutely. See, there's one of the engineer who doesn't believe this works. So let's look at it, right? So it figured it out from device instructions, which is the manual, that it should use send show command. I just told it to do quality of transmission. Quality of transmission is performance monitoring. So it used the manual to figure it out. This is the command you need to send. I had already told which device it is. It executed this command. And if you look at CLI, CLI is designed by humans, right? So it has pages worth of data. And it is for everything. It has data for the main chassis. It has data for every card in the system. And it is from infrastructure to CPU to processes. And it could reconcile everything and tell you exactly the root cause.
That's not my question. My question was, can you go back to the original output?
This is the output. You mean the reasoning output?
Yes.
Okay. Yeah, we need to wrap up. Anyway, we can take that question off now.
That little, what is that? The QOT report for R14. And then there's a little,
Oh, that.
It's markdown formatting, so you can copy that text. It's just, yeah.
It's not telling you the reference where.
Yeah, no.
Yeah, it's just that copy button.
Yeah, I think we're going to wrap up. For folks who are in Nokia, definitely we can have a session for your devices and we can onboard you folks. For folks who are outside Nokia, Letta, I think use the product. It's really good. It is designed for engineers and pretty simple to use. Thank you.
Okay, everybody, please welcome Dharmendra. Thank you very much.
Oops, let me take my machine.
it's scaring me. It's all like
Yeah.
there.
There's a lot of stuff
So
in there.
everybody, thank you very much for watching and attending. We're just going to kind of like mingle around and talk. So if you have questions for Dharmendra about what's going on, or you have questions for me, I'll be around. And then there's like some other members of the Letta team around. And then I would like you guys to thank, first of all, Dharmendra for getting us here, and then Patty, Jordan, who's running security, Julia, Luz, and other people, and then Yanni, is that his name? Yanni? So please welcome, please thank them for helping us out.
Yeah, so let's
Should it actually you get